In this problem, we're told a child goes down a playground slide with an acceleration of 1.26 meters per second squared. Find the coefficient of kinetic friction between the child and the slide if the slide is inclined at an angle of 33 degrees below the horizontal. So as usual, you always want to draw what's going on. So we have this child going down this slide, and they're going to be accelerating at a rate of 1.26 meters per second squared. And we know the slide is going to be inclined at 33 degrees. So that's the information we're given. And so let's talk about what we're solving for here. So we're going to be trying to find the coefficient of kinetic friction. So we call that mu sub k. And so in problems like these, generally the way you do it, solving for mu sub k, the only way to do it is by finding the force of friction and by using that formula. So we know the formula, force of friction is equal to mu sub k times F sub n. So if we want to find the force, or mu sub k, right, the coefficient of kinetic friction, what we need to do is find the force of friction, and we also need to find the normal force. So those are the two things we have to find if we want to solve for it. And so the way we find both these, and we're gonna do it by taking the sum of the forces in each direction. So we know, right, we're gonna take the sum of the forces in the x direction, and then we're also gonna take the sum of the forces in the y direction. So that's how you solve for both of those. So let's just go ahead and start with taking the sum of the forces in the x. So when I say the x direction, the way you want to think about it is this line right here is your x-axis. So everything along this line we call the x-axis, and then perpendicular to that is the y-axis. So you just need to keep that in mind. When I say the x-axis, I'm referring to this line right here. So just keep that in mind. So what we're going to do is take the sum of the forces in the x, and we know in the x direction, they're going to be accelerating at 1.26 meters per second squared, right? They're accelerating down like this. So we know the sum of the forces equal mass times acceleration, right? Because they're going to be accelerating. And then you want to say ma equals, and then what you want to do is sum of the forces in the x. And so in order to do this, what you want to do is draw the free body diagram of all the forces acting on our object. So in this case, it's going to be the child. And so what forces do we have? So we're going to label both the x and the y. So we have mg going straight down as usual, right? This is just going to be the force due to gravity. It's straight down. It's not at an angle. We also have the force of friction going back, right? This is going to be the force of friction. It's going to be slowing them down. And then we also have the normal force that's going to be going upwards against them, right? And we know it's going to be perpendicular to the incline. So it's not going to be straight up. It's actually perpendicular to the incline. And so what you also want to do is you want to make sure this mg force, right, the force due to gravity as a result of gravity or the weight force, you want to label it in the x and the y. So you want to find the x and y components. So if you think about it as a triangle, we have, right, if you look at it like this, and so essentially what we have, right, is we're going to have an x and y component. And so what we want to do is find the x component, because this is just going to be at an angle, but what we need to do is find the x component of it. So the way we do that is by drawing a triangle. So if I draw this triangle, basically what this mg is, it's the hypotenuse on our triangle. So mg is that, and then the angle is the same as the angle at which it's inclined. So 33 degrees. And what we're trying to do is find the x and y. So opposite to it is the x, and then this is going to be the y. So yeah. So if you look at it at a triangle like this, right, the opposite is the x, and then this is the y. So keep in mind the reason it's drawn this way. Look at the x. Notice it's along the x-axis, and then the y is going to be in the y-axis. So when we take the sum of the forces, keep in mind we can't just take it at this mg force the straight down, because it's not along one of the axes. So that's why we got to find the x and y component of it. So let's just start by finding the x component. And the way you do that is by using the sine function. So we know the sine of an angle is opposite over hypotenuse. So the opposite is x, and the hypotenuse is mg. So x over mg, if you go ahead and do that, you're just going to get the x component of the gravity, or the force due to gravity, is mg times the sine of 33. So that's the x1, right? That's going to be the one along the x. And then for the y, we're going to use cosine. So the cosine of an angle, we know cosine is adjacent over hypotenuse. So the adjacent is y, and the hypotenuse is mg. Multiplying both sides by mg, that's going to cancel out that there, and then you just get the y component of the gravity is going to be mg times the cosine of 33. So now we have the x and y for gravity. So now basically what we got is we can just go ahead and solve the x and y, because all of our forces, we found them in the right direction. So let's say ma equals the forces in the x. So now what we want to do is summarize the forces in the x. And so in this case, we're only going to have two forces. We're going to have the force of friction, which is in the x-axis, right? And it's negative because it's going in the opposite direction we're traveling. And then we also have another force, which is the x component of gravity, right? Because it's along this line. So we have to add the x component, which is mg times the sine of 33. So mg times the sine of 33. And then what we can do is go ahead and solve for the force of friction. So if we add it to the other side and then minus ma, you're going to get the force of friction, is equal to mg times the sine of 33, and then this is going to become negative, right, because we're moving it to the other side. So minus ma, and so now we have the force of friction, right? And so what we want to do next is solve for the normal force. And the way we're going to do that is by taking the sum of forces in the y this time. So we know the sum of the forces in the y, or F equals ma, right? But in this case, it's not going to be moving at all in the y, right? It only moves along the x-axis. It doesn't move at all in the y. That's going to mean its acceleration is 0. Because it's not moving in that direction, it can't be accelerating in it. So we know 0 is going to be equal to the sum of the forces in the y. And what we want to do is just add up the forces in the y direction, just like we did for the x. So in the y, we're going to have two forces, the normal force, and we're also going to have the y component of our gravity. So we're going to say equals F sub n, right? We're just adding the forces, and it's positive because it's going upwards. And then we have to minus mg times the cosine of 33 because it's going downwards. And that's just going to be the y component of our gravity. And so what this should tell you, if you add mg times the cosine of 33 to the other side, you just get the normal forces equal to it, which makes sense because it's the only force in the y direction. So now we have the normal force, right? We have the force of friction, and what we can do is just plug them in and we can go and solve for the coefficient of kinetic friction. So we know the force of friction is equal to mg times the sine of 33 minus ma, and then it's equal to mu sub k times F sub n, which is mg times the cosine of 33. And notice we're not given the mass, but luckily we can just cancel them out from each term. So the mass goes away in each term. So we just have g times the sine of 33 minus the acceleration is equal to mu sub k times g times the cosine of 33. So you want to divide by g times the cosine of 33 from both sides. So g times the cosine of 33. So you're going to get mu sub k equals g, and so you can use 9.8 or 9.81. I'm just going to use 9.8 to estimate for g, which is just the acceleration due to gravity. So 9.8 times the sine of 33 minus the acceleration, and we know we're accelerating at 1.26. So 1.26, and then we divide by g, which is 9.8, times the cosine of 33. So go ahead and plug this in, 9.8 times the sine of 33 minus 1.26, and then divide by 9.8 times the cosine of 33. And when you do that, you're going to get mu sub k, where the coefficient of kinetic friction is 0.496, 103, and so on. I'm just going to round to 0.496, and so keep in mind we don't have any units on coefficient or friction, right? Coefficient of kinetic friction or coefficient of static friction. There's no, it's unitless. So you're just going to get mu sub k equals 0.496. And so yeah, this is going to be your answer, and hopefully you found this useful.